so quick review as usual. Yesterday we talked about the applications of the nitrogen and water cycles and how the nitrogen and water cycles kind of come together in this example of fertilizers. We use primary productivity as a term for how fast plants grow in an ecosystem, how fast they put on biomass. And it turns out that a limiting nutrient is a chemical that you could add that'll increase that number. And that the limiting nutrient of most plants is the same. It involves nitrogen, potassium, and phosphorus. And so when farmers put a bunch of that on their fields, of course, it increases the nitrogen for the plants and they grow faster. But the water cycle comes in, runoff moves that fertilizer into aquatic ecosystems, and you get algal blooms that create dead zones. So that was our example for the water and nitrogen cycles. Then we played Are You Smarter Than a Harvard Graduate? You'll play it again tomorrow. The answer, of course, was no, but you're not any dumber. And the question was, where did plants get all that mass if it can't be created or destroyed? And of course, you remember, because it was just yesterday, that the answer was from the air, out of thin air. They take the CO2 and build those sugars by compressing those carbon molecules. Good. So then we actually went through the carbon cycle and saw that it's photosynthesis and cell respiration that make up the above ground portion. Dead stuff's been building up for billions of years, but humans have had a noticeable effect by moving the Earth's carbon reservoir from underground to much heavier in the atmosphere. And that's where we left off. Today, a couple of kind of disconnected concepts to end the chapter and move into chapter 4. The mosquito scenario that you started with before we started the chapter brings us into one of those concepts, that mosquitoes turn out to be food for an awful lot of things in wetland ecosystems, especially the larvae. You ever seen a mosquito larva? They're so gross. They don't even look like a bug. They're like these little tube worms almost. Here, I'll show you. That is a mosquito larva. And they just kind of hang there in the water, and if you disturb the water, they'll kind of squirt from place to place. They're just weird little things. But so many things eat them. So many fish and insect larvae, and I mean the dragonfly larva just has lunch all day on these things. That it turns out they're really important for that wetland ecosystem. And if you take them out, the wetland ecosystem can collapse. And you know the term for that, right? A species that so many different things depend on, that if you take it out, it'll collapse. Kevin?
How come we don't see a lot of larvae on the pond waters if there's so many mosquitoes?
You do if you look. They're just kind of hard to, you don't notice them. Like I've got a rain barrel in my backyard that collects rainwater, and if I don't put biological control, they're called mosquito dunks that actually have bacteria in them that kill larvae. If I don't do that, the thing is just packed with those little larvae in the summer. It's gross.
They only breed in stagnant water.
Exactly. They don't really breed in running water. It's only still water. Yeah, good. Thank you. So what do we call a species that so many different things depend on if you take it out of a collapse? Grant, did you have an idea? No, we'll get to that. It's actually an architectural term. Say it again. No, it comes from architecture. Okay, which is actually a field named after one of the first inventions of it, which is the arch. The way you build an arch, like a traditional arch. Here's what it looks like. You put two big heavy blocks on either side, and those are called the footers. And then you cut a bunch of blocks of stone that look like that, right? And you build a wooden scaffold to hold them up, and then you start stacking these stones up with the scaffold holding them up, and they kind of make that arch naturally. And then you put the keystone in. And once you put the keystone in, you can get rid of the scaffolding, and the whole thing stands on its own. No mortar or glue or anything required. The arch stands on its own. One of the cooler early inventions in architecture. And so why do we use that term for something like a mosquito? Or a salmon? Or a sea turtle? Braxton. Yeah, it's a direct analogy that if you take the keystone out of the arch, it'll collapse. And so keystone species is what we call a species that so many other critters depend on that if you take out, the ecosystem collapses. Loggerhead turtles are a good example, because they have an especially, we usually don't find out about these until they go away, and we've noticed that, hey, the ecosystem's not doing so well. Sea turtles, as you probably know, have an easily disrupted hatching pattern where they lay their eggs like 100 yards inland and they bury them in the sand. And then when the little babies hatch, they're on their own. They got to use their little flippers and get all the way to the ocean. And unfortunately, artificial lighting, like, you know, condos on the beach, messes up their navigation and they don't make it. Mosquitoes, man, I hate mosquitoes. We have a cabin that my dad and I built in way northern Wisconsin, and there are times where the mosquitoes are like an act of God. They will drive you inside. There's so many of them. But it turns out in an ecosystem like wetlands, they are a keystone species. And if you spray for them, as we love to do, right? There's places I've been where pickup trucks go around once a day and spray the whole island for mosquitoes. If you do that in a wetland, a bunch of stuff goes hungry and the wetland ecosystem starts to collapse. Another great example of something that is going away because we love to eat it is salmon, which is a fish that used to just be everywhere in the northwestern, you know, the Pacific Northwest in Canada. But man, they're delicious. So we take them from a lot of places, and it turns out there's a lot of other organisms that depend on them all through their life stages. Eggs and, you know, the early fry stages and even the adults. So that is keystone species. The other thing we got to kind of clean up is, you know how we say that all the energy that ecosystems get ultimately comes from where? The big nuclear reactor in the sky we call the sun. But I can't say that. I have to say almost every ecosystem depends ultimately for its energy on the sun, because there are a few that don't. And so we'll just mention what makes that work, which is a process called chemosynthesis. As you might guess, it's kind of like photosynthesis, but using the energy in chemical bonds. And not just any chemical bonds. Chemical bonds that get made by geological processes like volcanic activity. And so you find the bacteria, it's only bacteria that know how to do this. And only certain bacteria that we discovered really only 40 or 50 years ago. Best place to find it, well, easiest place to find them is in hot springs areas. You'll find some of them. But the coolest place to find them, where there's whole ecosystems built on them as the producer, is these geothermal hot sulfur vents. I think the one they really explored well is off the coast of South America, like out from the Galapagos Islands. And they sent a submarine down there. At some point this year, I'll show you the video where the ecosystem built on this is just crazy. You know, bacteria you can't see, but the things that eat them, you get these food chains where there's like these weird blind tube worms and crabs that look like nothing you've ever seen before, because none of it requires sunlight. And so they don't have to wait for anything to trickle down from above. They're building on that hot sulfur basis. Anyway, these are basically autotrophs that don't need light, and they're getting energy from molecules like hydrogen sulfide. We'll talk more about chemosynthesis a little bit more later, and I'll show you that video. But for now, I just need you to know it exists. And it's kind of the exception to that everything depends on the sun example. Where does new land come from? Where do we get new, like actually new land? How does that happen? You know at least one way it can happen?
Like volcano erupts, and then it was hit by a body of water, and then the magma will go out the water, and then the cool water will it'll turn.
So you know the Hawaii example, right? Yeah, it's so cool that like it's not even at the edge of a tectonic plate. It's like right in the middle. It's called a hot spot. And every once in a while, in that area where Hawaii is, the Earth will just kind of puke up another island, right? The lava comes up, and like you said, it cools and hardens and becomes rock, and you've got this island in the middle of the ocean. That's one really dramatic example of where new land comes from. Now, look at Hawaii, though. That's not bare rock. That's like a lush rainforest, right? How? How did we get from bare rock to rainforest? It's not that the ocean deposited like silt or sediment on the rocks. That's a good thought. That happens in lots of places, but not there.
Didn't birds like bring seeds over?
Eventually, yes. When birds poop out seeds, they can grow in places where there's soil. But we're not talking about a place where there's soil. It's just bare rock. Where did the soil come from? Good. I get to teach you that. So the process of bare rock becoming soil, becoming forest, is called primary succession, and it's a type of ecological succession. And the kind of ecological succession that you just told me about, where bare rock is involved, that's called primary succession. That's a kind of succession you've probably never really observed any of the stages of unless you've been to a place where there's volcanic activity. However, the second kind is called secondary succession. You live in the perfect place to watch. A place like Springboro, which started out as basically farm fields, right? And has gradually become like the place to be, the perfect halfway point between Dayton and Cincinnati. Mom works in Dayton, dad works in Cincinnati, live in Springboro. Means that what you've seen a lot of is clearing of land, and then often a delay between when the land is cleared and when it's developed into stores or houses or whatever. And you get to watch, like think about the corner of Austin and 741 that hasn't been built yet, right? That whole area they've cleared, but they haven't done anything with it. It's just been sitting there. What happens when, like, say, you stop farming a field and let it grow, or a forest fire comes through and clears the land, or a flood happens and then recedes, and you've got new land? It's got soil, but there's nothing growing on it yet. What order do you see to that process? What does the succession look like? What moves in first? Grant. Probably what? Oh, for sure, plants. Which plants? Say that again? Basic ones. What does that mean?
Grass, wildflowers.
Yeah.
Quick growth plants.
Usually grasses, types of grasses. That's a big group of plants. And wildflowers, basically things that get carried, the seeds get carried on the wind, and they can just float in and start sucking up nutrients and sun and grow. In your garden or your lawn, we would consider those what? Weeds. Yeah. They're the ones that move in first. Then gradually some perennials start to stick, and then you get some shrubs. And eventually, what do you get in this area as what we call the climax community? What are you going to see after 100 years? a forest, what we call a temperate or hardwood forest. Good, that's called secondary succession. And the difference is there's already soil, so it happens much more quickly. So about 4 years ago, I got in a really bad bike wreck. I was biking downtown with my buddies, and I hit a curb wrong on pretty thin tires. Went over the handlebars, and I'm telling you this, I don't remember it. This is just what my friends saw. And went to the hospital, was completely knocked out. Honestly, I don't remember any of that. And was severely concussed, like I had a concussion. Bad enough that like the next 3 months or so are a little blurry. Apparently, one of the things I did in that 3 months was apply for a scholarship program to go to Costa Rica. I don't remember doing that, but then that was like October that I got in the bike wreck, and in February I was kind of myself again. And I remember getting an email that said, "Congratulations, you've got a fully paid trip ticket for this teacher program to Costa Rica to learn about all this stuff." And I'm like, "Oh God, is this a scam or what?" And come to find out, no, it was it's a program. It's actually led by the author, one of the authors of your textbook. And I went back and I found even the essay that I wrote to get it. It's a very good essay. I don't remember writing it at all. Point being, I got to go to Costa Rica, and I got to be around an active volcano for part of it, and I got to see evidence of primary succession, whereas a lot of you probably haven't. Part of the program was learning how to take brief videos of ourselves in these kind of cool settings to teach your students about concepts. So this is a long introduction of me telling you that you're about to watch a video of me in Costa Rica talking about primary succession. Okay, give me a minute to get the audio together. Hey guys, back again in Costa Rica, out of the rainforest and into the dry forest because we gained some elevation. Behind me, see that? That is an active volcano. It's called Arenal volcano. And the rocks that you see all around here, this is a lava flow from 1992. These rocks were thrown all the way from there to here. And we're here because I want to talk to you about primary succession. We've talked secondary succession. You see old fields grow back all the time. This is what happens first. A lava flow, and then the pioneer species move in. So let's take a look. The first things, the pioneer species that tend to colonize lava first are lichens, okay? And these are the lichens here. It's a symbiotic relationship between an algae and a fungus. Then we have that followed by mosses, which you can see all around the lichens. And then some of the more adventurous plants, like the orchids you see here, and ferns, and bromeliads. So this is how an area of bare rock can turn into all the stuff you see around you. So yeah, it is the pioneer species that paved the way for everybody else. In the case of lichens, they do. They break up the rock and other stuff can move in. Eventually you've got soil, although it's usually fairly poor soil in rainforest areas like that. I'm going to give you the rest of the time to work on your charts. Any questions that you have about what should go in those boxes on the cycle chart, please ask those while you are here. You got a solid 10 minutes to work. Please use it. That is all.